The point of this particular objective is we know the shape that our magnetic field is supposed to be. It's supposed to point from north to south, and it's supposed to have more concentration near the poles. However, when you have a solenoid electromagnet, you can't always tell where north and south are. So, how do we figure out where north and south are? Is we're going to use what's called a right hand rule. So, for this part of class, you're going to want your notebook. I'm showing you the first of three right hand rules, and I want you to be able to tell them apart. So, first off, both solenoid electromagnets and regular permanent magnets have the same shape of field. They both point from north to south and have more concentration around the poles. If you took a look inside the permanent magnet, you'd even see that its domains line up with its field lines. Remember, inside the magnet, the domains point from south to north. Domains point towards the North Pole. And that actually forms the same exact shape as its solenoid counterpart. You'll notice that they both form curves, complete loops as they might be called, which I'll draw in green. In either case, it forms a complete loop that goes from north to south on the outside of your coil. In this case, the domains go from south to north on the inside of the permanent magnet, but then they go from north to south on the outside of the magnet, forming a complete loop. So we know they have the same shape. The only tricky part is, how do I tell where north and south are if they aren't labeled? So for this, we're going to use what's called a right-hand rule. And the right-hand rule comes from the fact that in our universe, the direction of current and the direction of magnetic field are always perpendicular to each other. So current is electricity. Electricity can create magnetism. We call this electromagnetism, and that's why we would call this a solenoid electromagnet. It's a coily electromagnet. So, how do we figure out where the North Pole is? The first thing you have to do is you have to figure out where the conventional current is. And because of this particular picture, that step was already done for me. I do suggest always do step one and double check it because, like, for instance, number 14 in your homework, sometimes they draw the wrong direction of current. So check that it's conventional current. Conventional current goes from the positive terminal of the battery to the negative. Next, and here's the tricky part. This is called a right hand rule for a reason. What I want you to do is take your right hand and give me a thumbs up. I want you to curl your fingers in the direction of current. And imagine you're grabbing this wire, right? For this, I actually grab a pen or a pencil and use that as my cylinder. What I want to do is I want to point my fingers in front of the coil upward, and that puts my thumb pointed left. Right? When I do that and my thumb is pointed left, that identifies the direction of the North Pole. For these, I strongly suggest use some sort of solid object as like a manipulative that you can use to like point your hand in the correct direction. So your thumb should be pointed at the North Pole. So what I'm figuring is I'll show you how to do two of them, then we'll go try them on our own, and then we'll give you time to start them in your homework. Okay, so example one. All right, step one, let's check the conventional current. This has a current labeled, and it points from positive to negative. So that's good. I can tell this is pointing from positive to negative because it's leaving the positive terminal of the battery and going towards the negative. Next, grab an object. Take your right hand and curl your fingers downward. Curl them around that object down so it's pointing downward in front of you. That puts your thumb in a specific direction. If you're having trouble picturing this, imagine putting your hand like this. Take your right hand and make this shape. Okay. So imagine grabbing your object, putting your fingers downward in front of that object, and that points your thumb to the right. That must mean B is a north pole, and therefore, because magnets are always dipoles, A is a south pole. So that's what we're working on for now, using these three steps to identify that B is a north pole, ergo A is a south pole. And if you wanted to from here, you could draw your shape of the magnetic field. It points from north to south. It's more concentrated around the poles. What I probably wouldn't do because of just like how overloaded your picture would be, I probably won't ask you to draw the domains just because your domains would now be in here. And that's a little bit much. That's a lot of different layers of stuff overlapping each other. The standard in this case is be able to identify where the North Pole is. And then obviously if that's the North Pole, then the other one's the South Pole. Okay, so one more. What if you didn't have that first step already drawn out and you had to draw the direction of conventional current? So conventional current goes from positive to negative. So I would need to draw that in myself as a first step, then curl, then point your thumb. So in this case, conventional current goes from positive to negative. It goes in front of the nail. So I need to find a way to make my fingers point left while my hand is curled into this thumbs up position. So don't uncurl your fingers from this position to try and make it work. Rotate your whole hand and wrist, right? Now, when I do this, if I need my fingers to point to the left, I have to like do some crazy, I need to like turn my hand all the way around. I can make my fingers point to the left, it's just uncomfortable. And the reason is in our universe, you have what's called right-handed symmetry. Your left hand is actually anti-symmetrical to this. So don't left hand this. Right hand rule only. And with the right hand rule, you're trying to point your fingers this way. If you imagine that current going behind the nail now, it would go back towards the negative end of the battery. So literally grab a pen or pencil and try to make your fingers point to the left using your right hand, keeping it in thumbs up configuration. I can do that. It's just going to be a little bit tricky. I can do it, but it does curl your hand in kind of a funny, uncomfortable way. It looks like this, right? It points your thumb down. So imagine I'm trying to take my thumb and point it down. It points my fingers to the left. That means the bottom pole is a north pole and the top pole is a south pole. And then from there, if I finish early, I can draw the field lines on top of that, pointing from north to south. Okay, so the homework assignment that goes along with this is the second page of the homework.